Welcome to myprojectbazaar.com. Next we see about the abstract of our product. Generally, solar energy is radiant light and heat from the sun that is harnessed using a range of ever-evolving technologies such as solar heating, photovoltaic, solar thermal energy, solar architecture, and photosynthesis. It is an important source of renewable energy and its technologies are broadly characterized as either passive solar or active solar depending on how they capture and distribute solar energy or convert into solar power. Active solar techniques include the use of photovoltaic systems, concentrated solar power and solar water heating to harness the energy. Passive solar techniques including orienting a building to the sun, selecting materials with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulated air. Solar power is varied time to time in day, so we need a constant power from solar energy that can be focused in this proposed work. In this design based on the incremental algorithm, that the incremental algorithm is improved for the purpose of obtaining the maximum power from the solar panel. This can be done by solar tracker and maximum power point tracker. The incremental algorithm provide enhancement of speed in maximum power point tracking. This approach includes two categories of controlling such as open and closed loop control. This implementation is done in MATLAB simulating environment. Our product title is Development and Comparison of an Improved Incremental Conduction Algorithm for Tracking the MPP of a Solar PV Panel. Next we see about the flow diagram of our product. This is our flow diagram. In our proposed design is using of solar panel to get the complemented power. Generally the solar power output is very low due to the irradiance conditions, so we need to increase the output power. So we using maximum power point tracking algorithm. Various kinds of algorithm are used. We designed the algorithm is a improved incremental algorithm. This is a corresponding incremental algorithm flowchart. Initially determine the V1 and V2. V1 is initial voltage and V2 is a reference voltage. Then compute the BK. BK means at each instant the output power is measured from the solar panel. That power is measured by using of measuring the voltage and current at each instant. Then compute the dV and dP, and next we check the condition. That condition is V of k is less than V1. That condition is satisfied, then the output of V of k is added with the incremental voltage. Otherwise the condition is not satisfied, then check another condition. That condition is V of k is greater than V2. If that condition is satisfied, then the output V of k is decremental by the change in voltage. Otherwise that condition is not satisfied, then check the other condition. That condition is dP bar dV is equal to 0. That condition is satisfied, then check dV bar dV is greater than 0. If that condition is satisfied, then output V of k is added with the incremental voltage. That condition is not satisfied, then V of k is subtracted by a incremental voltage. Then the overall process will be stopped. Next we see about the running process of our product. In this proposed design is done in MATLAB 2013 version simulating environment. First we open the MATLAB window. Now the MATLAB window is open. Then select the file and choose the new module. So now the module window is open. Here the simulating library is in MATLAB environment. In the simulating library the various elements are there. In our requirement, which elements are used in the circuit, so those elements are selected and tracked into the module window. Now the all elements are in the module window. Then connect the as per the circuit diagram. After that, we connect the scope and corresponding voltage and current measurement. Then simulating run symbol is here, so click that symbol. The window will be starts to run. After that, running the process, the output graph, that means the output waveform, are obtained in the corresponding scope windows. First one, we see the solar panel PV curve. This is the PV curve. Each every irradiance conditions, the power and voltage will be changes. That corresponding graph will be shown here. Next one, VI graph. The PV panel output V and I curve as per the irradiance conditions, and this is the scope window for corresponding voltage, current, voltage and power. The power is obtained the product of voltage and current. Then this is the saturation pulse waveform in obtained from the MATLAB function tool, and this is the corresponding output waveform. The maximum power is obtained at each and every irradiance conditions.